This question is from GATE 2018 Mechanical Engineering paper, set 2, question number 41. A 0.2 meter thick infinite black plate having a thermal conductivity of 3.96 watt per meter Kelvin is exposed to two infinite black surfaces at 300 Kelvin and 400 Kelvin as shown in the figure. At steady state, the surface temperature of the plate facing the cold side is 350 Kelvin. The value of Stefan-Boltzmann constant sigma is 5.67 into 10 to the power minus 8 watt per meter square Kelvin raised to 4. Assuming one-dimensional heat conduction, the magnitude of heat flux through the plate in watt per meter square is dash. Let's find out. Now here, as we can see in the figure, this cold side has the temperature 350 Kelvin and heat is flowing outwards towards the temperature 300 Kelvin. Of course, heat flows from higher to lower temperature. And this heat flow is taking place through vacuum. Temperature here is 300 Kelvin. So therefore, we can write for radiation heat transfer through vacuum, the heat flux, which is nothing but rate of heat transfer per unit area, Q, is given by sigma, Stefan-Boltzmann constant, into T1 raised to power 4 minus T2 power 4, where T1 and T2 are the temperatures of the surfaces between which heat flows. And here in this case, we can see that cold side is 350 Kelvin of the plate. The cold side of the plate is 350 Kelvin. And to decide what T1 and T2 will be, we will have to consider the heat flow between the cold side of the plate and the left side surface. And therefore T1 is 350 Kelvin, T2 is 300 Kelvin. Q will be equal to, Stefan-Boltzmann constant is 5.67 into 10 to the power minus 8. That's what we substitute. T1 350 to the power 4 minus T2 is 300 to the power 4. This when calculated in digital calculator gives us Q is equal to 391.584 watt per meter square. So this is the heat flux coming out from the plate. Now we know that through the plate, the heat flux inwards will be equal to the heat flux outwards. That is, the heat flux entering the plate will be equal to that leaving the plate. And therefore, when we write Q in is equal to Q out, the quantity that we have found out, which is heat flux coming out from the plate, will be equal to the heat flux through the plate, which is being asked to us. And therefore, Q in will be 391.584 as well. Unit of course being the same. So the answer here is 391.584 is the magnitude of heat flux through the plate. To learn more about steady state heat conduction, you can refer to the NPTEL video lecture 6 1D steady state heat conduction in plane wall from the course Conduction and Convection Heat Transfer. This course is taught by Professor S.K. Som. He is from Department of Mechanical Engineering from IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.